Hello everyone, welcome back to my YouTube channel. As you all know me, I am Ruchi HP, the student of Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Engineering, and my today's subject is Database Management System. And my topic is Introduction, Characteristics of Database Approach, Advantages of using DBMS approaches, History of Database Application. Contents: Introduction, Characteristics of database approaches, explanation of characteristics, advantages of using DBMS approach, explanation of advantages, history of database system, conclusion. Introduction. A database is a collection of related data. A data means known fact that can be recorded and that have implicate meanings. For example, consider the name, telephone number and the address of a person you know. You may have a recorded these details in an index address book, or you may have stored it on a hard drives using a personal computer or software such as Microsoft Access or Excel. This collection of related data with the implicate meaning is a database. Characteristics of database approaches. The main characteristics of the database approaches varies. The file processing approaches are the following: self-describing the nature of the database system, insulation between the programs and the data's abstraction, support of multiple views of the data, sharing of data and the multiple user transaction processing, self-describing nature of a database system. Self-describing nature of database system means that the database system not only contains the database but also contains the information about the structure and the constraint of the database. This information about the database structure and the constraint is known as metadata. Metadata is stored in a catalog of a database. Insulation between the programs and the data abstraction. In a file system, if some changes are made in the file structure, then to handle these changes or more changes have to be made in all the programs that access these files. For example, you want to add a piece of data, says date of birth of a student. Just adding it to the database is not enough. The whole program will have to be rewritten to make it work. But in database system, all you need to do is define another data items in a catalog called date of birth, and all the changes will be reflected and there will be no need to change the whole programs. Support of multiple views of the data. The database has multiple users. Each user may need different views of the database. The database view can be the information that is stored in the database or it's derived from the database. The database system allows multiple such views from the same database without letting the user to know whether the information is stored, just derived. For example, a teacher wants to call a parents of the student for a meeting. So, she or he will be having a different view which will be display the contact details of the parents. While if a student want to check the database for attendance percentages, he or she will only see the names of the students and the percentages and not the contact details of parents in his view. Sharing of data and the multiple user transaction processing. The multiple user DBMS, as the name suggests, means has multiple users. It must allow multiple users to access and use the database at the same time. This is must when the multiple application use a single database to store and integrate the data in one single database. To achieve this, concurrency control software must be included in the DBMS. Concurrencing the control software makes sure that the information is correct when multiple users try to access and update the data. Such applications are known as Online Transaction Processing Application (OLTP). Advantages of using the DBMS approaches: controlling the redundancy, restricting unauthorized access, providing persisting storage for programs, providing storage structure and searching techniques for efficient query processing, providing backup and recovery, providing multiple user interferences, enforcing the integrity constraints, permitting the inferencing and actions using rules, complex relation among data. Advantages: storage, security and efficiency. Under storage, controlling redundancy, persisting the storage for programming object. Under security, backup and recovery, restricting unauthorized access, enforcing the integrity constraints. Efficiency, storage structure and the search techniques, multiple user interferences, complex relation among data, inferencing the action using rules. Controlling the redundancy. Controlling redundancy means you avoid entering the same data multiple times. Why redundancy has to be controlled? Because of wastages of storage space and duplication of efforts and inconsistent data. Providing persisting storage for programs in a file system, objects are discarded once the program is closed, so the values of the variables are lost. DBMS recognizes the data structure of a programming languages like Java and C++, so it automatically converts and stores the objects permanently. Since the object survives terminations of the programs and can be retrieved again automatically is called persistent. Restricting authorized access. In a file system, if a user wants to access to some information, the user will have access to all the information. But in DBMS, we have advantages of restricting the unauthorized access. In DBMS, a person given access to all that information that he or she has permission to access. This is achieved by creating a different database user account with different privileges. Providing backup and recovery. The backup and recovery subsystem is responsible for recovering of the database in case of software or hardware failures. For example, suppose the system crashes in the middle of the transaction. The DBMS should make sure to restore the database to the state till where the transaction has completed and resume from there, or at least restore to the point before the transaction begin. Enforcing the integrity constraints. A DBMS have the capability to define and enforce the constraints for the data. For example, every values in the name column can have a maximum 50 characters, or age value of the student should not be less than 6 years, or the course ID for each student's ID should not be empty. This is called as a referential integrity, or that value of each course ID must be different. This is called as uniqueness constraints. Providing storage structures and research techniques. DBMS must provide efficient way of querying database and the updating database. Since database is stored on disk, DBMS must provide special search techniques and data structure to execute the queries faster. For faster query processing and optimizing, a DBA creates both index which are tree data structure and efficient queries for faster execution according to the index. Providing multiple user interference. A DBMS is designed to handle a multiple users at the same time. A DBMS has a different types of users such as stand-alone users, application programmer, web users, etc. So for different users, there are different user interferences. For example, a simple stand-alone user with less to no technical knowledge will be happy to be use a graphical user interference. An application programmer will need an user interference that is programming language interference. Representing the complex relation among data. A DBMS must have the capability to represent a variety of complex relation among the data, to define a new relation as they arise, and to retrieve and update related data easily and efficiently. Permitting inferencing and action using rules. Some databases have the capability to set some rules and to continuously check that the rules are compiled, and if the rules are compiled, then to do a specific action, and if the rules are not compiled, then to do another specific action. So the DBMS checks for these rules to see if the compiles or not after every update of the database and takes the approximate action. Database system briefs on timeline. Ancient time and 1968 file-based, 1968 to 1980 era of non-relational database, and 1980 present era of relation database and the database management system. The history of database system. In 1950s and early 1960s, database processing using magnetic tapes for storage. Tapes provides only sequential access, punched cards for inputs. Late 1960 and 1970. Hard disk allowed direct access to data. Network and hierarchical data models in widespread use. Toad code defines the relational data models, high performance transaction processing. 1980s. Research relation prototypes evolves into commercial system. SQL become industrial standard. Parallel and distributed database system. Object-oriented database systems. In 1990s, the large decision support and data mining applications, large multiple terabyte data warehouses, emergency of web commerce. Early 2000s, XML and XQuery stands, automated database administration. Later 2000s, gained data storage system, Google, Bigtable, Yahoo, Peanuts, Amazons, etc. Conclusion. In summary, the database approach characterized by centralized data management, consistency, and the data independency offers significant advantages over a traditional file system. These benefits include improved data integrity security, reduced redundancy, and efficient data access. The evolution of database application reflect the increased complexity and the volume of data, underscoring the importance of robust database system DBMS in modern computing. Thank you.